Good morning students. Welcome to grade 9 mathematics class. In the previous class we learned about rational numbers. What is meant by rational number, children? Do you remember? The numbers in the form of p by q is known as rational numbers, where p and q are the integers and the denominator value q is not equal to 0. Why not equal to 0? Any number divided by 0 is not defined. Okay, so that the denominator value should not be 0. Today we are going to learn about irrational numbers. Irrational numbers are the opposite of rational numbers. The numbers which cannot expressed as in the form of p by q is known as irrational numbers. An irrational number is a number that cannot be expressed as an ordinary ratio of two integers. An irrational number is number that cannot be expressed as an ordinary ratio of two integers. Okay, this definition you should learn. Okay, so before doing irrational numbers, before learning irrational numbers, you should know about the types of decimal numbers. That is easy to learn the irrational numbers. Okay, so what are the types of decimal numbers we have now? Decimal numbers are terminates and non-terminates. What is meant by terminates now? For example, 0.5. This is one decimal number. There is a end. And one more example, 1.2. 1.2 is the decimal number. There is a end. Similarly, one more example, 3.4. There is a end. This type of numbers are terminates. Now come to non-terminates. In this non-terminates, we have two types. Okay, non-terminates also we have two types. One is recurring. Recurring means repeating. Recurring means repeating. Another one is non-recurring. Non-recurring, that is non-repeating. For example, for recurring decimal is 1.333 etc. Okay, here same number is repeating. This type of numbers are recurring. Recurring means repeating. Recurring. Okay, non-recurring means, for example, 1.3567 etc. Different numbers are repeating. These types of numbers are non-recurring. So this non-recurring types of numbers are known as irrational numbers. Okay, this is rational, this also rational, this is irrational. Understand students? Only non-recurring types of numbers are known as irrational numbers. For example, here root 2. The value of root 2 is equal to 1.414 etc. Different numbers are repeating. So non-recurring. Okay, and no end. Non-terminates. Okay, in this non-terminate type, non-recurring numbers are known as irrational numbers. So irrational numbers are non-terminates and non-recurring. Okay, no end. There is no end and the same numbers will not be repeat. Different numbers will repeat. Understand students? And one more example, root 3. The value of root 3, if you are using long division method, if you are finding the value of root 3, this value of root 2, root 3 using long division method, last year you may learn. Last year you learned. Okay, so root 3 is equal to 1.732 etc. Different numbers are repeating. Okay, so non-recurring. But root 4 is not an irrational number. So why? Root 4 is equal to 2. Okay, it is irrational. 2 can be write 2 by 1. So 2 is the rational number. Root 4 value is 2. 2 can be write 2 by 1. So 2 is the rational number. Similarly, root 9 also. Root 9 value is 3. That also rational number. Okay, 3 can be write 3 by 1. Okay, so except perfect square number, remaining numbers are the irrational numbers. Okay, so irrational numbers means you understood now, is it non-recurring type of numbers. Okay, repeating, but same numbers will not be repeat. Okay, different numbers will be repeat. Okay, this type of numbers are the irrational numbers. Okay, and one more example, pi. Pi is also an irrational number. Pi, irrational number. Irrational number. Okay, the value of pi is 3.1415 etc. etc. There is no end, but different numbers are repeating, so non-recurring. Okay, this type of numbers are irrational numbers. Okay, understood, students? So in book page 45, page number 45, examples are given. Root 2, root 5, root 7, 2 root 3 etc. are the irrational numbers. And also pi. Pi is an irrational number. Then the number e, also known as Euler's number, is another common irrational number. So e is the common irrational number. Okay, these examples you have to learn. Okay, now let us do one problem. Okay, so now example 2.2. What is the example 2.2? Now represents the following as decimal form. Two questions are given. First one is minus 4 by 11 and the second one is 11 by 75. One by one let us do. First one is minus 4 by 11. Leave the sign. There is negative sign is there. Leave it. Last we can take the negative. Okay. Now we are going to divide 4 and 11. So 4 by divisor is 11. 11 is the greater number, so 4 cannot divide by 11. For that we have to use the decimal, 0 point. So here also we have to use the decimal. So after the decimal, let us take some zeros. Okay, 1, 2, 3, 4 as service we can take the zeros. Okay. Now first we have to take it, this 4 and this first 0, it become 40. Okay, now say the 11 table, 11 3s are 33, 11 3s are 33. Now we have to subtract this 40 and 33, we get 7, is it? Then next 0 we have to take it down, so it becomes 70. Why 7 is cannot divide by 11, so next digit we have to take it down. Okay, now again say the 11 table, we get 6 11s are 66. Okay, subtract it, we get 4. Okay, now also 4 cannot divide by 11, we have to take the next digit. Okay, so next digit 0, so it become 40. Now 3 11s are 33. Subtract it, 7, 0. So 6 11s are 66. Subtract it, 4, 0. 3 11s are 33. Okay, etc. etc. Subtract it, 7, etc. It will be go without end. Okay, so it can be right 4 by 11 is equal to 4 by 11. There is a minus, so minus 4 by 11 is equal to minus, here what are the value we have? 0.36363 etc. Okay, so 3636 same way repeating, so we can write 3636, same numbers are repeating means we can give the bar. Okay, 3 and 6 is repeating, so in place of, instead of etc, we can use the bar. 3, 6. Both numbers are repeating. So we can give the bar for both numbers. Okay. If it is only one digit is repeating, we can give the bar for that number alone. That digit alone. Understand, students? So the value of this one minus 4 by 11 is minus 0.36 bar. Okay. Similarly, we are going to do the second subdivision. Okay. Second subdivision is 11 by 75. 11 by 75. Here 11 need to divide it by 75. So 75 is greater number. So we cannot divide 11 by 75. So we have to use the decimal 0 point. So here also we have to use the decimal. After that we can use the zeros. Okay. Numbers of zeros as our wish we can take. Now this first digit, first 0 take it with this 11. So this 11 become 110. Okay, 110. Now 175 is 75. Subtract it, 110 and 75, we get 35. Again 35 cannot divide by 75. So next 0 we have to take. Now it become 350. Now see the 75 table 4 times. 4 times 75 is 300. 300. Subtract it, 50 is the balance. This 50 cannot divide by 75. So next 0 we have to take it. It become 500. Now 6 times 75 is 450. Now subtract it, 50. Next 0 take it, 500. Again 6 times 75 is 450. Subtract it, 50. The next 0 take it. One more 0 make it. Next 0 take it. 6 times 75 is 450, etc. etc. Okay. So here we can write 11 by 75. 11 by 75 equal to 0.146666 etc. which is equal to, here no negative, only positive is given. So negative symbol we should not use here. 0.14. The number 6 alone repeating. Okay. So here we have to use the bar for the number 6 alone. Understand, students? Bar means that's the number alone repeating. Okay. Bar meaning is the number alone repeating. Understood, students? Now in page number 47 there is a tabular column. So first 1, reciprocal of 1 is 1 by 1. As a decimal form 1 can be write 1.0. There is a end, so it is decimal representation of 1 is terminating. Understood, students? You have to learn from this. One word can be asked. Okay. Now next, another number 2. Reciprocal of 2 is 1 by 2. The value of 1 by 2, if you are dividing, we get 0.5. There is a end, so it also terminating. If there is a end, it is called terminating decimal. Okay. Next 3. The reciprocal of 3 is 1 by 3. So if you are dividing 1 and 3, just now we divide that procedure, we get 0.33333 etc. There is no end is called. So here it can be read 0.3 bar. 3 is repeating. So 0.3 bar. So there is no end. 0.3333 etc. So types of decimal representation is non-terminating recurring. Same number is repeating means that is recurring, but there is no end, so it is called non-terminating recurring. Okay, next 4. The reciprocal of 4 is 1 by 4. 4 if you are dividing, 1 dividing by 4 we get 0.25. There is a end, so it is terminating. Now 5. Now the reciprocal of 5 is 1 by 5. So if you are dividing 1 and 5 we get 0.2. There is a end, so it is terminating. Now 6. The reciprocal of 6 is 1 by 6, which is equal to 0.16 bar. Okay, here 16666 etc. Okay, so it is non-terminating and recurring. Similarly, next 1 by 7. The value of 1 by 7 is 0.142857 etc. etc. Same numbers will repeat. Again the same 6 digit will repeat. Again that same 6 digit will repeat, like that. So this type of numbers are non-terminating and recurring. Same numbers are repeating means that is recurring. Okay. Next, the value of 8 is, reciprocal of 8 is 1 by 8. When we divide we get 0.125. It is, there is a end, so it is terminating. Okay. Then 9. Reciprocal of 9 is 1 by 9. When we divide we get 0.11111 etc. So it can be write 0.1 bar. So there is no end. It is called non-terminating and same number is repeating, so recurring. Understand, students? Then there is 10. The reciprocal of 10 is 1 by 10, which is equal to 0.1. There is a end, so it is terminating. Okay. Next, let us do the exercise problem. So exercise 2.2, first question, first subdivision. What is the question? Now express the following rational numbers into decimal and state the kind of decimal expansion. Okay, kind of decimal expansion means whether it is terminating or recurring or non-recurring, we have to find out. Okay, first of all we have to divide the number 2 by 7. Okay, let us divide 2 by 7 and what type of this decimal we have to write. Okay, let us divide it. 2 divided by 7. 2 by 7. Here 7 is the greater number, so cannot be divided. So we have to use the decimal point. We have to use the decimal point. So here after the decimal we can use the zeros. Okay. As service we can take the decimal. Now first of all, first digit take it together, it become 20. Now 2 7s are 14. Subtract it, 6 is the balance. Next digit take it 0. Now see the table, 7 8s are 56. 4 is the balance. Next digit take it 0. So now 5 7s are 35. Subtract it, 5 is the balance. Next digit take it 0. So here how many times? 7 8s are, now 7 7s are 49. 1 balance 0. 1 7 is 7. Balance 3. Balance 3. Further 0 take it. So 7 4s are 28. Subtract it. 2. Next 0 take it. 2 7s are 14. 2 7s are 14. Subtract it. 6 0. How many times? 8 7s are 56. Further the same, see here 2 8 5 7 1 4. Again 2 8. Same numbers will repeat. Okay, etc. etc. Okay, same numbers will repeat. So this can be right. 2 by 7 equal to 2 by 7 equal to 0.28571428 etc., etc., etc. So here this 285714. So this 6 digits will repeat again. Okay. So this can be write 0. So if you are finding again the same 6 digit only will repeat again and again. So this can be write 0.285714. All these 6 digits will repeat again. Okay. So we can give the bar for all these 6 digits. Understand, students? So types of decimal. The question is asked to express the following rational numbers into decimal form. This is the decimal form and they asked to state the kind of decimal expansion. Can you say what is the kind of decimal expansion? Is it recurring? Yes, repeating, no? So it is recurring. Same numbers is repeating, means that is recurring. Is it terminating? No, there is no end, etc., etc. Is it? So non-terminating and recurring. Understood, students? Same numbers are repeating, means that is known as recurring. There is no end, so it is non-terminating. Okay, so we can write it is non-terminating and recurring. Okay, it is non-terminating and recurring. Recurring meaning is repeating. Okay, understood, students? There is a homework. Exercise 2.2. First question, third subdivision. First one I completed. Third question, third subdivision homework. Okay, 22 by 3. 22 by 3 is homework. Second and fourth subdivision in the next class. Okay, first of all you have to practice the classwork portion well. After that you have to do the homework. Okay. Exercise 2.2. There are 4 subdivisions. First one I completed. Second and fourth one in the next class. Third one is the homework. Okay, same as this first one method. So you have to complete it. These are the today's question. Thank you, students.